Tonight's video lesson is the last video lesson for this unit, and so lesson 6 is going to talk about elements and compounds. My objective for tonight's lesson for you guys is that you'll be able to distinguish between compounds and elements. My other objective is that you'll be able to identify when a chemical reaction is taking place and what exactly is a chemical reaction. To begin with, we're going to review a little bit about elements here, and you guys already know from previous videos and material we've covered in class that elements are found on the periodic table and that they are composed of a single type of atom that has a set number of protons, neutrons, and electrons. There is no way to break down that element into something smaller and still have all the properties of the element. So for example, this piece of copper, if we broke it down into just its protons, neutrons, and electrons, would no longer behave as a piece of copper. They would just have the properties of a proton, neutron, or electron. And we go about grouping these elements as metals, nonmetals, or metalloids. Another example of our element here is if we take sulfur. So sulfur is a nonmetal on the periodic table. It has its set of properties. It's a brittle yellow solid that does not conduct electricity or heat, whereas copper is a metal that conducts heat, conducts electricity, has an orange metallic color to it. It's malleable, and it's also solid. Now, if we compare this to compounds, compounds are composed of elements that have been chemically bonded together in a fixed proportion. You interact with compounds every day. One example of a compound that you interact with would be water, H2O, and that's 2 hydrogen atoms and 1 oxygen. All water molecules, no matter where you are in the universe, always have 2 atoms of hydrogen and 1 atom of oxygen. Now, compounds, like water, can be broken down into elements by chemical means. So we could do a chemical reaction to break down water into hydrogen and oxygen. What we cannot do is use a physical means to separate out the atoms or the elements that make up a chemical compound. So you could not use paper chromatography or filtration or distillation or evaporation to separate water into hydrogen and oxygen. Compounds are also not found on the periodic table. The elements that make up the compound are, though. Just like elements, we can group compounds into 2 categories, ionic compounds or covalent compounds. Our next unit, you're going to get more information about that, but for right now, I want you to know that there are 2 groupings of compounds. So for example here, our piece of copper from before looks like this, and then I've got here a jug of copper nitrate. So the copper, like I said before, has a set of physical and chemical properties. And the copper nitrate is going to have its own set of physical and chemical properties. One's a solid right now and one's a blue liquid. They will not behave the same way. But we could do chemical reactions to break this back down into copper and nitrogen and oxygen. Another example of a compound that you're familiar with and you interact with every day, and as part of our diet, would be table salt. So table salt is composed of sodium and chlorine. Sodium is a metal that explodes in water, and yet it doesn't explode in your body when you consume this. And chlorine is a poisonous gas. But when you combine them as chemical compounds, it creates something that we crave. We want this as part of our diet. You would not be able to function without sodium chloride or table salt. As another comparison between elements and compounds here, ignore the Russian on this slide, but silicon's on the left-hand side of the screen there, and that's a metalloid with a set of properties. And on the right-hand side, we've got silicone, which is used a lot in cooking materials because it's heat resistant. They each have their own physical and chemical properties that separates one from the other. Now, as part of our discussion of elements and compounds, we're going to tie this to what we were talking about before about heterogeneous and homogeneous mixtures. So everything around you, including yourself, is made up of matter. And there's a way to classify this matter as either a mixture, an element, compound, or a solution. So to begin with, because everything's made of matter. Is it uniform throughout? If you answer yes to this, it's a homogeneous mixture at least. If you answer no, then it's a heterogeneous mixture. We know some examples of heterogeneous mixtures. Chicken noodle soup is one. Your desktop in the classroom is another. Homogeneous mixtures are just like the Kool-Aid that we worked with in class. It's the same throughout. Now the next question is there a difference in the composition of it? Now we talked about before in this video here that compounds are always composed of the same thing. Water is always H2O. But we can make something like Kool-Aid in a number of different ways, and it still is a homogeneous mixture. You can add more sugar, less sugar, change the water, add 2 packets of Kool-Aid there. As long as you get it all mixed together, it's still a homogeneous mixture. If it has to have a set composition, like water of H2O, that's referred to as a pure substance. And pure substances then can be split a little bit further. If you can break it down by chemical means, that is a chemical compound. If you cannot, then that is an element. And the only thing you're going to get if you go any further is protons, neutrons, electrons. The last part of our video here is about chemical reactions, which is going to help us get ready for the next unit here. Because we're not always talking about things like copper just sitting on a counter. What I'm interested in, what you guys are interested in, is most likely how those elements or chemicals react with each other. And so reactions occur between 2 or more elements or compounds, and they're going to result in the formation of a new set of compounds with properties that are different from the starting material. And these are both physical and chemical properties. And so when we talk about chemical reactions, the starting material we always refer to as reagents, and the products is what we create during that chemical reaction. And this is similar to like in math, if you have a formula there, and you know, x plus whatever value that you're adding to it, those are your reagents or reactants there, and what you're producing or what you're solving for is y. So how do we know if we have a chemical reaction that's taken place? There are 4 indicators of chemical reactions. The first is that there's a formation of gas. So if you've looked at baking soda and vinegar before, that produces carbon dioxide, and that's what causes it to foam up over the side of whatever container you're working with. If there is a drastic color change, so our heating of the Kool-Aid here today, the fact that the Kool-Aid became darker green as we heat it up, that's not a drastic color change. What would be a drastic color change is that the sugar that was left behind on the side of the beaker, as it burned, it turned black. And that's because we were combusting the sugar there and turning into carbon dioxide, water, and a couple other smaller products. Another indicator is a change in the temperature. This does not mean that the temperature's increased when I put it on a Bunsen burner, okay? The temperature change has to come from the mixture of just those reactants. So if you've ever used like a hot pack or a cold pack before, in a lot of cases, though, that's the result of a chemical reaction. The temperature has to change just from being mixed together. And our last indicator, which we've already seen this last week, is the formation of precipitate. Now, precipitates are formed by 2 liquids being mixed together, and they're going to form at least one insoluble solid that we would then be able to separate out by the use of filtration. That's our video lesson for tonight. Make sure you have your video guide completed. We're going to take a quiz on this on Monday when you come in, and have a good weekend.